When a star wanders too close to a black hole, it doesn't just die in a brilliant explosion. It gets stretched, shredded, and devoured in a process with a wonderfully strange name: spaghettification. This is just one of the mind-blowing truths about our universe we're going to explore today. The cosmos is filled with wonders that defy our everyday understanding, from secret moons that tag along with Earth to colossal structures so vast they challenge how we think the universe works. So get ready, because today we're diving into 7 facts that will change how you see everything. Let's start with that terrifyingly cartoonish term: spaghettification. The official name is a tidal disruption event, or TDE, and it's one of the most violent things in the universe. Picture a star, a giant ball of gas millions of times bigger than Earth, making its usual orbit around the center of its galaxy. But this time, its path veers just a little too close to the galaxy's central, supermassive black hole. Here's where things go wrong. The black hole's gravity isn't uniform. It pulls on the near side of the star with immensely more force than the far side. This tidal force starts to stretch the star into an egg shape. As it gets closer, the force becomes overwhelming. The star is literally pulled apart into a long, thin streamer of gas, just like spaghetti. As this stellar noodle falls toward the black hole, it whips around, forming a massive, superheated disk of debris. The friction is so intense that the disk lights up, and for a few weeks or months, this single event can outshine a galaxy of billions of stars. We are quite literally seeing a star's final brilliant scream as it gets eaten. For years, we only saw these events in the centers of big galaxies, but fascinating discoveries have found them in unexpected places, like one spotted far from a galactic core, suggesting a rogue black hole is wandering the outskirts. It's a chilling reminder that these cosmic monsters aren't always where you expect them. Not everything that gets close to a star is doomed. Some objects are true daredevils, performing a celestial dance with death and coming out completely transformed. I'm talking about sun-grazing comets, massive balls of ice and rock that hurtle toward the sun on extreme, looping orbits. Most are vaporized by the intense heat or torn apart by gravity, ending their journey in a puff of gas. But some survive. And when they do, it's a show. Take the Kreutz family of comets, which are all thought to be fragments of one giant comet that shattered thousands of years ago. Again and again, these pieces dive toward the sun. Many perish, but some emerge. Changed. A recent example had astronomers on the edge of their seats. A newly discovered comet, C/2024 S1 Atlas, made this perilous journey. Observers held their breath, expecting it to disintegrate. Instead, as it whipped around the sun, it underwent a stunning transformation. The intense heat and gravitational stress didn't just destroy it. They sculpted it. The comet temporarily blossomed, creating a beautiful and complex tale from what should have been certain destruction. While this particular comet did eventually fragment, its brief survival was a spectacle. These events show us that destruction and creation are often two sides of the same cosmic coin. Think you know Earth's neighbors? We have one moon. That's it, right? Well, not quite. It turns out our planet sometimes collects temporary new friends called quasi-moons. These aren't true moons, gravitationally locked to Earth forever. They're small asteroids, caught in a special orbital dance with us. They still orbit the Sun, but their path is so in sync with Earth's that, from our point of view, they seem to hang around, tracing a complicated corkscrew pattern as we both journey through space. These relationships are fleeting. After a few hundred years, their orbits drift, and they break away from us to continue their own journey. One of the most fascinating is an object named Kamo-Oaliiwa. It's been our quasi-moon for a while, and will stick around for centuries more. But here's the mind-blowing part. Scientists studying its composition realized it didn't look like a typical asteroid. It was a near-perfect match for rocks on the moon. The leading theory is that millions of years ago, an impact on the moon blasted a chunk of its surface into space. That chunk eventually settled into its current orbit around Earth. So, not only do we have a temporary second moon, but it's a long-lost piece of our actual moon that's come back to haunt our orbit. We're used to thinking of space as being full of, well, stuff. Stars, galaxies, nebulae. But what if I told you about a place defined by its staggering emptiness? Astronomers have found just such a place, and it's called the Void. Discovered in 1981, it's a colossal, nearly spherical region of space, often nicknamed the Great Nothing, and earned the name. This void is roughly 330 million light-years in diameter. For an area that big, we'd expect to see thousands of galaxies. Instead, we've found only about 60. To put its scale into perspective, if the Milky Way were at the center of the Botti's void, we wouldn't have even known other galaxies existed until the 1960s. So where did everything go? Voids like this are a natural part of the universe's large-scale structure, which resembles a giant cosmic web. Gravity pulls galaxies into long filaments and dense superclusters, leaving vast, empty regions behind. The Botti's void is likely the result of smaller voids merging over billions of years. It's a stunning example that the universe's structure is defined just as much by what isn't there as by what is. For most of history, finding planets around other stars, exoplanets, was a game of shadows. We'd look for the tiny dip in a star's light as a planet passed in front, or the slight wobble in a star's position from a planet's gravitational tug. We knew they were there, but we couldn't actually see them. That's changing. We are now in the era of direct imaging. Thanks to incredible technology, we can take actual pictures of exoplanets. This is a monumental challenge. Imagine trying to spot a firefly next to a giant searchlight from miles away. That's the scale of the problem, as a planet can be 1 billion times fainter than its star. To pull this off, astronomers use instruments called coronagraphs, which are basically highly sophisticated masks that block the overwhelming glare of the parent star. This is often paired with adaptive optics, which are computer-controlled mirrors that instantly correct for the blurring caused by Earth's atmosphere. The results are breathtaking. We're no longer just guessing. We are seeing these distant worlds as distinct points of light. By analyzing that faint light, We can learn about their atmospheres, finding hints of water, methane, and clouds. It's the first step toward the ultimate goal, directly imaging an Earth-like world and searching for the chemical signs of life. The James Webb Space Telescope isn't just an observatory. It's a time machine. Light takes time to travel across space, so when we look at distant objects, we see them as they were in the ancient past, and Webb is giving us the clearest baby pictures of the universe ever taken. What it's finding is both exciting and deeply puzzling. One of the biggest mysteries is how supermassive black holes got so big, so fast. These are the monsters at the center of galaxies, with masses millions or billions of times that of our sun. Our models suggested they needed a very long time to grow. Yet, JWST is finding them fully formed in the cosmic nursery. In a landmark discovery, Webb found an actively growing supermassive black hole in a galaxy that existed just 570 million years after the Big Bang, when the universe was less than 5% of its current age. This cosmic toddler already had a mass of millions of suns and was eating voraciously. It's like finding a full-grown adult in a room full of newborns. These discoveries are forcing scientists back to the drawing board, rewriting the first chapters of cosmic history and showing us that the early universe was far more advanced and chaotic than we ever imagined. Almost everything in our solar system was born here, formed from the same disk of gas and dust that created the sun. But we're not entirely alone. In recent years, we've confirmed that we're getting visitors, interstellar objects. These are comets or asteroids that formed around other stars, got ejected, and have wandered for millions of years through the empty space between the stars. In 2017, we spotted the first one, the mysterious Oumuamua. Then, in 2019, came two I/Borisov, which looked much more like a typical comet. And in 2025, a third visitor was confirmed, named 3 I/ATLS. Unlike the fleeting and mysterious glimpse we got of Oumuamua, astronomers had a better chance to study 3 I/ATLAS, an active comet that developed a coma and tail as it approached our sun. Each of these interstellar travelers is a priceless message in a bottle from a distant, unknown solar system. By studying their chemistry, we can learn if the building blocks for life are common elsewhere in the galaxy. Are other solar systems made of the same stuff as ours? With new observatories coming online, astronomers expect to find more of these interlopers every year, turning these rare events into a steady stream of cosmic messengers. The universe isn't a silent, static void. It's a dynamic, evolving, and often violent place where stars are eaten, galaxies dance across millions of light years, and we get visitors from other stars. It's easy to feel small in a cosmos this vast and strange. But these facts should also make us feel connected. Every atom in your body was forged in the heart of a star that lived and died long ago. The carbon in your DNA, the oxygen you breathe, the iron in your blood, it's all stardust. You aren't just living in the universe. You are the universe, experiencing itself. And what a privilege that is.